Here's a parametric one. They give us the velocity. So if that's x comma y, this is like x prime, y prime, dxdt, dy dt, gives us an initial position. So when they find the x coordinate of the position at t equals 2, so what we want to know, this is kind of how we set these up in the past. I said, I want to know the x position at t equals 2. I would start with the initial position at t equals 1. And then I would pick it up where I left off, go from 1 and then go to where I want to go of that 2. And then this would have been like our dx dt right here. All right, so then our initial position at t equals 1 was the 3, where they gave us that. And then you're going to integrate. You're going to pick it up at 1, go from 1 to where you want to go to 2, integrate that dx dt in between 1 and 2. So that tells you how far you went. Take into account the initial position, math 9 that thing to get that answer right there. For part B, it says the line tangent to the curve has a slope of 2. So when they give you the slope of the tangent line, they're telling you the dy dx. The dy dx is equal to 2. At what time is the object at that point? So we know the dy dx is equal to 2. We also know on all these parametric ones, the dy dx is the same thing as dy dt over dx dt. So set that equal to 2. They gave us both the dy dt and the dx dt. So I just plug those in. Anytime you have a complicated equation to solve, this is what you want to do on the calculator part of the test. You're not really meant to solve that. You could solve, the calculator will solve it for you. So move everything to one side, set it equal to 0, and then graph this function right here. You're only in between 0 and 1. So once you graph this function, if you hit zoom 6, it might be a little chaotic, I'm not sure, but then when you hit the window button, make your x min 0, your x max 1, and then calculate that 0. If you forgot how to do that, please rewatch the graphing calculator video where I show you how to approach that. And I'm actually going to review that on this particular problem right there. I already got this set up in my calculator, but make sure you can get that number. If not, let me know. For part C, the speed formula is simply the square root of dx dt squared plus dy dt squared. Now, a lot of times they have us find the speed, but here they're telling us that speed is equal to 3. So I got to set that equal to 3 and then find that time. And so there's my dx dt, there's my dy dt. So I just plug those in there and squared them. And on this complicated equation, I moved everything to one side, set it equal to 0. I'm going to graph this in my graphing calculator. So I already have that in there. And so I'll scroll over so you kind of see how I entered that in with all the parentheses and everything. And the first thing I did, and then I remember that -3. The first thing I did was just hit like zoom 7, like a normal trig graph right there. And then when I did that, it just kind of popped up like that. Sometimes it's chaotic and I'll go back in, I'll use like whatever window they give me, but here I didn't need to worry about that. I just need to, there's only one spot where it's crossing the x-axis. So I want to find the 0 of that equation. So remember, again, I'll hit the trace button and I'll put my cursor in that vicinity. And then you're going to hit second trace. That's your calculate menu. Hit number 2 where it says 0 and it says left bound question mark. So you need to make sure that cursor is to the left of that x-intercept. On an increasing function, it's going to be below the x-axis, so my y value is negative. Hit enter. And then right bound question mark, you need to move it to the right of that x-intercept. So on an increasing function, it's going to be above the x-axis. So I'm going to hit my right arrow and I'm going to pay attention to the sign of my y's. Once my y's change sign, then I'm good. I can hit enter right there. So you narrowed it down up between above and below that x-axis. So where it says guess, I never really usually guess. You already narrowed it down. Hit enter a third time, and then you're able to get that 2.196 number. So you're going to use that same technique on letters B and C. It's just 2 different functions right there. But again, you have to always show your setups. They know you're using the calculators to do the calculations, but you have to have the setups there. And then like what you're like entering into the calculator right there. So always show the setups of your equations, your integrals, that's your work, that's your justification. And then the total distance traveled, the same thing as the arc length formula, which is going to be the integral of that speed formula. So I did the integral of this guy in between 0 and 1, and then that's going to be a math 9. So I already got this set up for you. So you're going to hit the math 9 button and you're going to type it in there. So you kind of see, I'll scroll over so you kind of see how I entered everything in with the parentheses and everything. And then once you hit enter on that, we should have that 1.595 number. Curly hair, Curly from the Three Stooges, curly fries.